Let's talk transformations. Write a rule to describe each transformation. First off, we have 3 transformations. We have translations, and those move things left to right or up and down. We have rotations, which rotate things to a certain degree. Like a 180-degree rotation would be to turn something completely around. If you do a 180-degree rotation, instead of facing forward, you're now facing backwards. And then lastly, we have reflections, which flip things. And usually we flip these over an axis, so we flip it over the x-axis or the y-axis. So now we talked about our 3 different transformations. We need to decide which one is being shown in the image. So if we look, here's our original. Our original is the original letter, so A, B, N. As you can see in the blue one, it says A prime, B prime, and N prime. Those little apostrophes at the top, they're just saying A prime, B prime, N prime, and that just means this is your transformed image. So this one is our transformed image, and this one is our original. So how do we get from the original to the transformed image? Did we translate? Did we just move it? So if we just moved it, it would stay in that same shape. So it would have this shape as the triangle. So we can see it doesn't have the same shape. It's not in the same direction. So it could either be rotated or reflected. So if we look, we have that x-axis in the middle. This is 4 squares down, and this is 4 squares up, which means it was reflected across the x-axis. When it's reflected, it'll always be the same distance from that axis, from that middle point. Let's look at number 2. We have our original image, the black image, and then we have our transformed image, the blue image. So we want to see what happened here. Did we translate it, reflect it, or rotate it? So I always like to check translated first to see if it's in the same position. So as we look at this shape and this shape, it is in the same position. So we could just move it up and move it over to make it get to that spot. So then we just have to figure out how much we moved it up and how much we moved it over. So to do that, we pick a point. So I'm going to pick point S. And I'm going to see how many points I had to go up and over to get to this next S, to S prime. So I went up 1, 2, 3, 4, and I went over also 4. And if you want to check to make sure it's a reflection, check another point. See if you also go up 4 and over 4. So if we look at N, we went up 1, 2, 3, 4, and then over 1, 2, 3, 4 to get to that N prime. So we can say that this is a translation. And we went up 4, right 4. All right, let's look at the next 2. Number 3, we have our original image, and then as you can see, it looks kind of like the opposite across from the y-axis. So if we see that y-axis is our divider, C is the same length away, L is the same length away, and U is the same length away. I like to think of this as like a taco shell. So if you like folded the taco shell over the axis, would they line up? Would your pieces line up? So if we folded those 2 triangles, we folded that paper across the y-axis, would the 2 triangles line up? And yes, they would. So since we can fold them, it is a reflection across the y-axis. Let's look at number 4. We have our original image here, and then we have our new image in blue. So translation, that would mean we could move V, I, and R all over and up and down to make this same image. But you can see that the triangle has been flipped. So if I moved it down, it would look like this, and it doesn't look like this shape. It's kind of flipped around. So we're not going to use a translation because our image has been either rotated or reflected. So if we think reflection, if we look at either our X or Y axis, can we fold the paper across that axis and have the two images line up? Well, no, because they're diagonal from each other. They're not right across from each other across the axis. So then our third transformation is our rotation. So if we look, we can see that we're rotating our image down into quadrant 3. So this is quadrant 1, 2, 3, and 4. So if we take that image and we rotate it down, it will match up. So each point is rotated to the next point, meaning that this is a rotation. And it is a 180-degree rotation around the origin, which is our center point. Another way to think about rotations is if you put this triangle on the hand of a clock. So if you think about this graph like a clock, and we put that on the clock handle, as the clock handle ticks down this way, if the triangle was taped to that clock hand, as it rotates down, would it match up with this image? So if that clock analogy works for you, please use it as you think about your transformations. I would like you to try problems 5 and 6 on your own and answer the questions in Edpuzzle to check your work. And when you're done, the remainder of the packet is your practice.